Hi everybody, happy Friday. Today we're going to go through our second lesson in Unit 9. You will need a calculator for today's lesson. You are going to need some type of scientific calculator. You can access that on your phone or online. I'm going to be using a graphing calculator. If any of you have that, you don't need one of these. What you're looking for on the calculator to know if you have the right one or not, or you're using the right one or not, are the buttons sine, cosine, and tangent. So if you're using a calculator and you can locate those buttons, you are using a correct calculator. In case you're using a graphing calculator, I know like a few of you have been using this in class, I just want you to make sure you're on the right mode. So when you turn your calculator on, I want you to go to the mode button. And it might be hard to see on the video, but the third or fourth line down, it says radian and degree. I want you to make sure on your calculator degree is darkened. And if it's not, you just toggle down with the arrows, move over to the word degree, push enter. And then we're gonna push second mode, which is like the quick command. That's just if you're using a graphing calculator to make sure you're on the right mode. If you're not using a graphing calculator, you don't have to worry about that. So for problems 1 through 3, it says use your calculator to find trig values. Round your answer to the nearest thousandth. So basically the first couple problems here are going to be really easy. You just need to know how to locate the sine, cosine, and tangent buttons. So my sine button is right here. I'm going to type this in exactly like I see it. So the sine I just pushed, I'm going to insert 40 degrees. I don't need to insert the degree symbol. I'm just typing sine of 40 and pushing enter, and I get a big long decimal. And I'm gonna write down that decimal to 3 decimal places because that's the nearest thousandth. So 6, 4, and then I have a 2, but the next digit is a 7, so that would bump up the 2 to a 3. Number 2 says find the cosine of 70, so I'm gonna type cosine 70, push enter. A big long decimal comes out. I'm gonna round to 3 decimal places. So I have 3, 4. I have a 2 then for the next number. After that is a 0. So the third decimal place will remain a 2. And then lastly, we have the tangent of 58 degrees. I get 1.60, the next digit is a 0, the one after that is a 3, so that thousandth place will remain a 0. So again, first couple problems are just getting comfortable with the calculator, locating those buttons. The next problem says solve each of the following equations, round your answers to the nearest hundredth. So, what we're going to be starting to take a look at in the next problems are actually solving trig ratios for a missing side length. So I have the sine of 73 degrees equals x over 15. So remember the sine ratio is equal to opposite leg length over hypotenuse. So I am unclear in this problem what the opposite leg length relative to the 73 degree angle is, and that's what I want us to find here. I am gonna go through these problems a little bit particularly, so what I'm gonna do, what I like to do is actually make this look like a proportion, a fraction equal to a fraction, because we just spent a long time talking about proportions, and we know that we can cross multiply in order to solve a proportion. And I'm gonna do that. So I don't want you to just maybe use your calculator a little bit too quickly. Like I know I could put in the sine of 73 in the calculator, but I'm gonna talk about why I'm not doing that in a second here. So the first thing I'm gonna do is cross multiply. So my first cross product, I get 1 times x, which would just be x. The second cross product, I'm multiplying 15 by the sine of 73 degrees. I'm always going to put like the coefficient of the trig ratio first rather than last, because that's going to help me when I put it into the calculator. Now, what I have right here is the exact value of x. And I want to know what that is. So that's why I didn't go ahead and just type in sine of 73 into my calculator right away, because the calculator gives us a decimal, big long decimal, that goes on and on and on forever. So I want to know sometimes what the exact value is before you tell me the rounded value. So these problems on this slide are telling you to round to the nearest hundredth. So I am going to pick up my calculator now because I figured out what the exact value of x is. So I'm going to type in 15. You could push the times button if you want to. Sine of 73 degrees, and I'm going to push enter. So I get 14.34. So when you're going through these problems on homework or tests or quizzes, I do want you to make sure that, like on homework, you're giving me exact answers before you're giving rounded answers. And on a test or a quiz, I will try to make that like explicit, but I am looking for exact answers before rounded answers. So I'm going to do the same thing for the second one, try to make it look like a proportion, because I know I can solve a proportion by cross multiplying. So my first cross product, I'm multiplying x by the tangent of 50. And again, I always write the trig ratio last and the number or the variable first. My second cross product, I get 4. 1 times 4 is 4. So I need to isolate x in this problem. So I'm multiplying x times tangent of 50. So what operation undoes multiplication? It's division. So I'm going to divide by the tangent of 50 on both sides. So on the left, I'm left with x. On the right, 4 divided by the tangent of 50. And again, this is your exact answer. Now I'm going to figure out the rounded answer. So I'm going to type this into my calculator. So I type 4 divided by tangent of 50, push enter. I get 3.3, the next digit is a 5, but the one after that is a 6. So I'm going to bump that next digit after the 3 up to 6. So the next couple of problems, we're given a diagram and we want to find a particular side length. So in the first one, we want to find the length of AC. We have to now set up our own trig equation, our own trig ratio. So I want you in these problems to locate the acute angle that is given to you. So that's the 58 degrees. Again, we never write trig ratios based off of the right angle. And I want you to take a look at the side length that you're given. So I'm given 7. What is 7 in relation to the 58 degrees? Is it the opposite leg? Is it the adjacent leg? Or is it the hypotenuse? Well, 7 in relation to this 58 degrees is the adjacent leg, and I'm actually going to go ahead and label that. Then I want you to look at what length you're trying to find in relation to the 58 degrees. So what is x in relation to the 58 degrees? Is it the opposite leg, adjacent leg, or the hypotenuse? Well, x is across from the right angle. So x is the hypotenuse of this triangle. What trig ratio has adjacent and hypotenuse in it? if we have SOHCAHTOA handy, I know that cosine has adjacent and hypotenuse in it. So I'm going to set up the cosine ratio of the acute angle, so 58 degrees. Again, I like to put it over 1 so it looks like a proportion. And cosine is equal to the adjacent leg length, which is 7, over the hypotenuse, which I don't know, and what is the whole goal of this problem. So the first step in these problems that I do want you to spend some time doing is figuring out, are you going to be using sine, cosine, or tangent to solve the problem? That's important. Then we're going to cross multiply. Again, in front of the trig ratio, I always write the number or the variable I'm multiplying. I always put that first. I'm multiplying x by the cosine of 58. So I'm going to divide and undo that multiplication. So the exact answer of x is 7 divided by the cosine of 58. So I'm going to take my calculator, type that in. I get 13.2. This one doesn't tell me how to round, so I'm going to round to the nearest hundredth, 2 decimal places. So I have a 2, then a 0, but the digit after that is a 9, so it's going to bump the 0 up to 1. All right, so the next one says find the length of BC. So I'm going to put an X there. Again, I'm going to find the acute angle in the problem, which is 65. And then I'm going to ask myself, the given side length is what in relation to the 65? Is it the opposite leg, the adjacent leg, or the hypotenuse? It is the adjacent leg. What is the length I'm trying to find in relation to the acute angle? Is it the opposite leg, the adjacent leg, or the hypotenuse? This is the opposite leg. So going back to SOHCAHTOA, what trig ratio has adjacent and opposite in it? Well, that's going to be tangent for this one. So I'm going to set up the tangent of the acute angle. Again, I like to put it over 1. Tangent is equal to opposite leg length over adjacent leg length. So that's how we spend the time to figure out what trig ratio we're going to be setting up. Once we do that, I'm going to cross multiply. Once I cross multiply, I do automatically get the exact value of x. So I'm going to take my calculator now, punch that in. Again, this one doesn't tell me how to round. So I'm going to round this side length to the nearest hundredth. So that would be 25.73. So on the last page, we have some examples where I'm looking for us to find the perimeter of a triangle. So in the first triangle, we're only given one side length. So in order to find the perimeter, I need not just one side length, but 2 side lengths. So I'm going to label the 2 missing side lengths x and y. And I'm going to focus first on finding the value of x. So I'm going to locate the acute angle given to me and the side length I'm given. So in relation to the 36 degrees, 49 inches is the adjacent leg. Well, what is x in relation to the 36? It's the opposite leg. What trig ratio has opposite and adjacent in it? That's the tangent. So the tangent of the acute angle, tangent is opposite over adjacent. I'm going to go ahead cross multiply. And I'm going to figure out what the rounded value of x is using my calculator. Again, it doesn't specify how to round. So when I'm not told how to round for side lengths, I'm going to round to the nearest hundredth. So I have 60, the digit after that is a 0, so it's going to keep this a 0. So x is 35.60. Now, I need to figure out, though, what y is in order to find the perimeter of this triangle. So I'm going to, again, go off of the given side length. So I'm going to use the adjacent leg in relation to the 36-degree angle. Now I'm going to ask myself, what is y in relation to the 36-degree angle? Is it the opposite leg, the adjacent leg, or the hypotenuse? Y is across from the right angle, so y is the hypotenuse. So I'm going to use hypotenuse, because that's what I want to find, and the given exact value of 49 inches, 49 inches. So what trig ratio has adjacent and hypotenuse in it? That's cosine of the acute angle. Cosine is equal to adjacent over hypotenuse. I'm going to go ahead and cross multiply. I know that the exact value of y would be 49 divided by the cosine of 36. I'm going to pick up my calculator. 5, 6, and then I have a 7, so that's going to bump the 100th place up to a 7. And then the last step is just to find the perimeter. So I have to add up all 3 side lengths. So I get 145.17. In the last one, it says in the diagram, BC equals 110 inches. So BC, 110 inches. What is the perimeter? Round your answer to the nearest tenth. Now, this one's a little bit trickier. So I need to find the perimeter of this entire large overall triangle, not including, this is called the altitude, the segment in the middle of it. So what I'm first going to look at finding is, I'm going to look at this triangle on the right, and I'm going to find the length of CD. So in relation to the 33-degree angle, I have the hypotenuse, and I want to find the adjacent leg. So I know I'm going to be setting up cosine, cross multiplying to figure out what the value of x is. I'm going to pick up my calculator. Now, I know it says round to the nearest tenth. I'm going to round my final answer to the nearest tenth to follow those directions. But I'm going to find all these side lengths to the nearest hundredth and then round my final answer to the nearest tenth. Now, in order to start to move to the triangle on the left, I actually need to figure out what the length of BD is. So, again, in relation to this triangle and the 33-degree angle, y, or BD's length, is the opposite leg in relation to 33 degrees. So I want to use the exact non-rounded value of 110 and find the value of y. So what trig ratio has opposite and hypotenuse in it is the sine ratio. Sine is equal to opposite over hypotenuse. I'm going to cross multiply. and figure out what y is equal to. So 59.91. That's going to help me get into the triangle on the left. So this is 59.91. So I need to start to find these two side lengths. So I'm going to start by finding AD. I labeled that with a Z. So in relation to the 45-degree angle, Z is the adjacent leg. In relation to the 45-degree angle, Y is still the opposite, the 59.91. And W is the hypotenuse. So I'm first going to start out by finding Z. Based on Y's value, which I know is rounded, but that's the only thing I have to go off of. So I don't really have a choice. So what trig ratio has opposite and adjacent in it? That's tangent. Of the acute angle, tangent is opposite, which is 59.91, over the adjacent leg, which is Z. I'm going to go ahead and cross multiply. And then figure out the rounded value. And I get 59.91. In the next unit, we'll talk about how we know this is an isosceles triangle. Or we'll talk about special right triangles, which this is here. And then the last piece is to find W, because again, my goal is to find the whole perimeter of this triangle. So I'm going to go based off of the 59.1, the opposite leg. I want to find the hypotenuse, so I'm going to set up the sine ratio. Sine is equal to the opposite leg length over the hypotenuse. I have my exact value. And now I have the rounded value. Oops. 84.7. The next digit is a 2, but after that is a 5, so I'm going to bump that up to a 3. So I need to find the perimeter of this large triangle. So the perimeter, I have to add up these 4 side lengths. So I'm going to take my calculator, just do that quick. I get 346.89. But again, this did tell me to round to the nearest tenth. So I'm going to round the final answer to the nearest tenth. So that 8 in the tenths place is going to be bumped up to a 9. And that just allows me to get a more accurate answer.